So we've done about 20 million square feet of hospital space design. Okay, so that's a fair amount of learning, that we have had, and we are a firm who's based out of India and Middle East with about 160 people. Out of which 50% are people like you. Okay, so we run a design studio in Dubai also, where we have I think about 20 odd guys like you, and maybe 30, 35 here. Okay, this is the way we are structured. So one of the advantages that we carry with us is that a colleague of mine who wants to give you a lecture, she's an architect. I am a doctor. The lady sitting next to me also is a doctor with an MBA in hospital management. Somewhere, here will be an interior designer, biomedical engineers, everybody under same roof, all working full time. Okay, that's our major advantage. Okay, now look at what India is in healthcare, and that is why we exist today in India. We need as a company. Look at beds per thousand, beds per lakh, sorry, 90 as against the world average of 270. Okay, so that's the kind of, so we need about 22.5 lakh beds to be pushed into healthcare in India. Okay, look at doctors per lakh, look at nurses per lakh, look at the public health expenditure as percentage of GDP. You understand GDP? Okay, you are fifth year students, right? Yes. So GDP is, so India is actually not spending as much. So this current government has hiked this 1.33 now to inch towards 2, So that's why more money is now pushed into healthcare. So that's good for us, good for India also. But again, total healthcare expenditure also, India is much lower than other countries. Okay, and when I am talking other countries means when I compare with say Brazil or Argentina, or China, I'm not comparing us with US or Europe where these data are much better. Then also we are way behind. So that is why there is a big scope of healthcare. If you look at a reality check, we are organized as public health, so there's a lot of government infrastructure. There are corporate for-profit hospitals, then there are charitable trusts, not-for-profit, and then wherever you live, you must have seen small little nursing homes, scattered all over. Okay, it's a largely unregulated market. That's one of the problems, that there are no standards that hospitals follow. There is lack of skilled manpower, high cost but limited accountability for quality. Okay, and what I'm trying to do is I'm trying to tell you about how the market of healthcare is all about. Lack of technology, underdeveloped payer mechanisms like insurance, so people don't access healthcare, which is going to change. Have you heard the name of Ayushman Bharat? Have you heard the name of Ayushman Bharat or no?
Yes.
Huh? Can someone tell me what it is? You have not heard. Okay, so Ayushman Bharat is actually an insurance scheme which was launched on 23rd of September 2018. It's about 2 months old scheme. Okay, what this scheme is doing is 10 crore families in India will be covered for a cashless and free insurance of 5 lakh rupees per family. Okay, so me, as a very, I would say, upper middle class person, had an overall family insurance of 5 lakhs maybe about 5 years ago. Okay, now probably it's a little higher. But this is what government has given to below poverty line people residing in, rural areas, semi-urban, even in cities, that they will get a cashless and free insurance of 5 lakhs per family. Okay, and with this insurance, it is portable across India. Means anywhere you go, you can use this insurance card. Earlier, existing illnesses were not included. So suppose if I am a cardiac patient, I will not be insured for any cardiac illness. That has gone. Okay, so you will now be treated irrespective. 3 days prior, 14 days post treatment expenses, all will be reimbursed. Okay. Public hospitals are also allowed to charge, which will generate local budgets. So suddenly you will find your hospitals in districts and other places will start improving because they are going to generate their own local budget. Very, very revolutionary, kind of a change which is going to come in. Scheme is voluntary, so hospitals who don't like the scheme can opt out. Okay. So here the central government is giving 60% of funds, state government has to use 40% of the fund. This is one single, intervention which the government has made, which is going to change the way healthcare is going to be delivered in India in future. A lot of hospitals were not willing to put up, projects in rural India or mufassil areas in India because they were not sure how poor man will pay for it. This has resolved that. Okay, 5 lakhs is a fairly good size budget for a family to get treated. So this is a very and it's sort of win-win for almost everyone, because it is the patient is when the person who's treating is getting cashless insurance, and they say that in 21 days they will reimburse. All right. So this is one thing which is going to change the way healthcare is delivered. One more thing that I would like to share with you is look at this slide. This is investment and a bird's eye view of the return which happens. So medium range hospital, you the cost is about 25 to 50 lakhs per bed. Okay, this is excluding land, but including building and equipment. And a high-end super specialty hospital like Apollo or Hinduja or Lilavati, this will cost you about almost 50 lakhs to 1 crore per bed. Okay, I don't know whether you have ever heard this word, but there is something known as IRR, which is internal rate of return. Okay, what this means for you as a layperson is that when you borrow, if you take loan to buy anything like a computer or a car or a house, there is a certain loan amount, right? 10% or something like that. So if whenever you do a project and you calculate this IRR for the project, this IRR has to be higher than the rate at which you are borrowing money. If that is not so, you should not do the project. Okay, this is a very simplistic thing, which is probably you should know. These all are opportunities that Indian healthcare has, which is not only hospitals, but you will have Ayurvedic centers, fitness centers, pharmacy, medical store businesses, education like nursing, physiotherapy, dentistry. Okay, there is a fair amount of software startups which are happening in healthcare. You have those bags, which you carry around. There is a kitchen, laundry, facility management, outsourcing. I can tell you a story of a doctor who came to me for setting up a hospital, Dr. Shashi Balyan, and ended up setting up a laundry, for hospitals in Gurgaon. Okay, this guy is a doctor, and he set up a laundry. He didn't go for the hospital project. He went for a laundry, and he has 1 lakh square feet of a laundry in Delhi, which does only hospital laundry. Hospital laundry is a little different because you have blood stains and other things, which is there. Okay. And then there are these others, imaging centers, naturopathy centers, laboratories standalone. So healthcare is not only about hospital. Healthcare takes a lot of things along with it. Okay. One thing that you need to understand about us is that healthcare expenditure goes up drastically when you grow more sicker. So one of the things which is happening world over is the emphasis on not trying to do too much of hospital care, but also trying to invest in preventive health care. So this fitness center concept has come out because of that. So with this little bit, let me just launch into some. So this is something, a slide which you would like. If you guys want, I can email this, or I can just put this presentation somewhere and you can share it yourselves. So generally we need per bed area is about 800 square feet per bed. Okay. Now look at the bed required in India. It's 2.3 million beds we need in the next coming 10-15 years. Built up area required is 184 million square feet. Construction cost 4,000 rupees a square foot. Overall investment requires so much. Okay, and this is how that investment is. So what I'm trying to tell you, that there is enormous amount of scope which is going to happen in healthcare, and these are some of the figures that you can see. Okay, now why you need someone hospital to be planned properly, because it's extremely important. What you see in blue is doing right things right first time. I give this as a definition of quality. If you want to define quality, And quality means doing anything that you do it right in one shot. Very easy, to say, but very difficult to do. Okay, when you do your own assignments, just look back and see how many pages you tore up before you made the final one, right? So it's extremely important that you design a structure in a manner that you're for someone else who's going to invest, is going to have that building for next 40, 50 years. So you should not go wrong. Okay. Minimal standards for hospital engineering in our country, so we don't have too much to rely upon. You have to probably do fair amount of research. Okay. Hospitals are highly engineered, and subject understanding is very poor. Okay, not many that you will find who understand. I would say that having seen many building, I think hospital is one of the most complex in terms of engineering. It's a 24-hour working, 365 days, highly, completely air conditioned. Electrical system need to operate at its full, capacity. You have intensive care units where things can't go wrong. So hence, there's a lot of IT which is coming in. It's highly engineered, in that sense. More than 50% cost of hospital project is in the building itself. Okay, and 40% of that is in mechanical, electrical, and plumbing. MEP is mechanical, electrical, and plumbing. And why you need to be sensitive when you do this? Because at the end of the day, whatever you are spending, you are going to recover from the patient, right? And you need to be sensitive that you are using right kind of material, which is probably optimal. Now look at this. At the top, you have 20 to 25 acres of land. 1 million square feet of built-up area. Okay, for a medical college campus. Look at the bottom. You have a 200, 300 square feet bed squeezed in building of a nursing home, and in between is the other hospital. Okay, what I'm trying to convey here is that the variety of designs that happen is from a small nursing home to a large 1 million square feet kind of a campus. So it becomes very different. Area per bed comes from functional space programming. So in a space program, you actually do an Excel sheet. I'll just give you an example. This you should do. Forget it whether you're designing a hospital, whatever building you design, you should first make a functional space program. Okay, so if I do a functional space program of OPD, उसमें क्या आएगा? आप किसी भी हॉस्पिटल के ओपीडी क्लिनिक में जाएंगे, you will have a reception. Yeah, then you will have OPD clinics, right? So at reception you will say 150 square feet OPD clinic, 10 into 150 square feet, one store room, 100 square feet. Okay, managers cabin 120 square feet, two toilets, male and female, 240 square feet each. Am I right? So so that is the first step. Once you do the space program, you know how much area you need. So that space program will have to be done for all departments in a hospital or in any building for that matter. Okay. Let us now talk a little bit about how complex is the engineering. Okay. So there is an architectural briefing document, so in which the space program is one, but apart from that, we generate a program called departmental needs program. Okay. So say suppose I am taking an example of MRI. How many of you have heard of an MRI? Suna hai na? So MRI is a magnetic resonance imaging. That's the full form of MRI. Okay. That means there is a magnet in that machine. What does that mean? Since it's a magnet, 6 meters from the bed where the patient lies, you cannot have any moving metallic part. That means you cannot have an elevator. Okay. You cannot have a car going below. If you are on the ground floor and there is a driveway below, then a car cannot go. Okay. Similarly, anything else which is like a car going on the road and you are on, the MRI is just at the edge of the building, it will not work. Okay, what will happen is the car will not get stuck to the MRI, but the magnetic field will get vitiated and images will not be good. Okay, that's one thing about MRI. The second thing about MRI is it's a 10 to 14 ton machine. Okay, so your slab of the building will have to be designed to take that load, right? Then there is a radio frequency cage which will have to be created around it. So this is a very atypical need which architects wouldn't know. Okay, similarly, there is LINAC. So LINAC is linear accelerator. This is used for cancer treatment. Okay, for giving radiation to patients. Now linear accelerator, the wall thickness of this room is about 6.5 meter. Sorry, the height. The wall thickness is about 6 feet thick wall. It requires all around. All right. So that's something that you would never do. It's like a bunker that has to be designed. Plus, then there are norms where how that entry will happen. It's a tunneled kind of a walkway. There's another different way of dealing with it. Say for example, operation theater, which is an OT. So in operation theater, there are minimum sizes as given by certain norms. So 400 square feet is an operation theater minimum. Also, the issue is that it should generally be square and not a rectangle, because otherwise it will create an air turbulence. Because it needs a particular type of air conditioning. Okay. Plus, say an operation theater needs air conditioning in a manner that this is operation theater. Then there is pre and post operative room areas, changing areas for doctors. Every time that you come out, the air will need to be under lesser pressure. So more positive in operation theater, least positive as you come out of the operation theater complex. All these things will need to be defined by someone. Okay, so we prepare an architectural briefing, document for the architect. You will also need to understand traffic assumptions at peak load. Okay, so like say for example, in an OPD which has 10 doctor clinics, how much should be the waiting area? Can anyone, tell me a logical way of going about it? So let me just give you some logical way, and that you can apply to other, things also. Say one patient will take about 15 minutes with a doctor. Is that safe to assume? Yeah. So in 1 hour, you will have 4 patients. Okay. So I have 10 OPD clinics with 40 patients, and you should probably consider one patient with one relative. So there are 80. Is that right? Let's take 20 more. So 100 people waiting area you will require for a 10 OPD clinic. Correct? Now, what is your code says, that one person needs how much area to sit? If I say 4 square feet, is that good enough? आपका वो क्या standard होता है ना मैडम? What are standards that you call? There is some book.
Building bylaws.
Yeah?
No, Newford standards and time saver standards.
Yes. So that takes about 4 square feet per person sitting. So if you take 100 people, 4 is 400 square feet, तो minimum जगह केवल बैठने का लगेगा, है ना? Apart from that, you will need some circulation area, passages, and all of that, isn't it? Is that right? So you will have to have certain assumptions that you will have to make as a designer, and you can take some help from people who understand this. Maybe talk to a doctor, talk to a nurse, like that. Okay. Then we also will should know a little bit about broad guidelines on engineering. That there are certain norms about sterility. Okay, that you cannot enter certain areas in certain. Say for an operation theater, it should be dirty, semi-sterile, sterile. So you enter with street clothes, you go into change rooms, you change that, come into semi-sterile area, pre and post operative. Then before entering into the operation theater, there is another change of slippers, and then you get into. So it's dirty, semi-sterile, sterile. And when the reverse happens, it also has to follow the same path. It cannot happen that a sterile mixed with dirty direct. Okay, so that kind of sterility requirements will be there, which you will need to know. Okay. Then we need, hot water somewhere. We need somewhere. Say for example, an intensive care unit. An intensive care, critical care, ICU बोलते हैं जिसको, है ना? तो क्या लगता है आपको एक ICU में कितना प्लग पॉइंट होना चाहिए? Just guesswork. So each ICU bed will need about 8 to 10 plug points. Okay, and they will have to be at a particular height. Alright. Now you will need to know this. So these kind of things will form the architectural briefing. Any expansion need you will need to know now. Okay. Why? Because you cannot size a water tank probably later. Okay. When you are making provisions for a generator or transformer, you need to understand that a 200 bed facility is going to become 300 beds and it will need more power, more water. Okay. So that spaces you will have to keep today. You are going vertical, you will have to keep foundation accordingly, like that. So future expansion needs will need to be understood. Local rules brief. Are you guys from where? Navi Mumbai, Mumbai, where?
Yes, Navi Mumbai. That is correct.
Uh, so
But
say if you're doing a hospital in Bombay, very different than designing a hospital in Delhi. Okay, because ground coverage in Bombay you can go as high as 50%. What's a good ground coverage, by the way, guys? You understand ground coverage or no? So, what is a good ground coverage as an architect? यार जवाब तो देना पड़ेगा ना ऐसे थोड़ी ना 20 40 40% is very high. Am I right? I mean, faculty also can help you. 40% is very high. 25 to 30% is what generally municipality allows you. In Bombay they allow you more because Bombay doesn't have land and one has to go vertically up only. But otherwise you go to Delhi, 25, 30 in a max situation they will allow you 35%. Okay, so all these kind of, so when we say design in, say if you are designing in Andhra Pradesh, okay, then they just say that this is the setback, related to height. There is no concept of FSM. Okay, they say that this is the, if you go 30 meters, you leave 9 meters. If you go 40 meters tall, you leave 12 meters. If you go 50 meters tall, you leave 12 meters from the setback. The building gets defined by that only. There is no FSI. We design buildings in Dubai, there is no FSI rule. Okay, just setbacks and other things. So all the local rules. So we are now, going to do a campus planning for a medical college in Meghalaya, which is on a hill. Okay, so hilly regions again rules differ. Okay, so this is a briefing document that we make. This is a design team. This you guys would know. Only additions are facility planners or hospital consultants or people like us. Who will be extra biomedical engineers. You will need because technology needs will have to plug in when you design. Otherwise, the rest of it mostly is there in all the other buildings also. Okay, and nowadays there is a green building concept. I hope you guys know that, right? Yeah. So there is a different green building standard developed by IGBC for hospitals. And your Navi Mumbai Apollo Vashi Hospital was the first hospital to be given LEED, certification. Okay, as a platinum certified hospital. Okay, you guys can go and see that hospital. If you want, we can try and arrange a visit there also. Not a problem. Then these other things probably will come naturally to you. These are other things that we generally do: seismic belt topography, soil test, and all of that. I'm not going to deal much into that. I'm not going to do only in this slide. You need to understand that hospital buildings need higher floor heights. Okay, because we are centrally air conditioned, and nowadays government is not allowing flat slab designs for public utility buildings like hospitals. So you need to go with a beam slab, and that means that air conditioning will go below the beam. So we need about 4.2 meter height for hospital buildings. Okay, which generally in residential will be 3.3 or 3.6. Okay. Have you heard of a service floor? How many of you know what is a service floor? सुना है? Okay, I'm quite happy to hear so many of you say yes. Yeah, that's very good. So my job is done. So that is a must in hospitals, and this is generally about the operation theatre, because in hospitals each operation theatre will need one air handling unit. You know what is an AHU? Okay, all right. I'm quite happy to hear that. So in every operation theatre needs a dedicated AHU. So what we do is we put the operation theatres, on say second, third floor. Then we put a service floor so that all AHUs are on the service floor. And then we take all inpatient floors on top of it so that all the plumbing which is coming down, because generally toilets are towards the corridor, the plumbing then gets diverted at the service floor and goes out of the building. Okay, so that service floor is a very important criteria for us. Location has to be as per the fire now, so that is something that we can't do anything about. So one thing that is very sacrosanct to us is the planning grid, the column grid which is there. So let me just go to. I will just skip this. So this is important for us, in terms of the grid. All those red squarish things you see are the column grids, and for us, if you see the operation theatre that you just went by. So this operation theatre suit, has to be beam free. Okay, there should be no column. So we generally, what we do is we take the grids as standard. So if you look at uh, uh, 6.5 to 7.5 to 8 to 9, so but we generally for private hospitals go with an 8 by 8 meter grid. Okay, and for public hospitals or smaller charitable trust hospitals, we go with 7.5 by 7.5 or 6.5 by 6.5. Okay, so that's the kind of grid that works best for hospital. So it can take an operation theatre, it can take an ICU, okay, it can take a laboratory. So it's more flexible to go with a higher grid, larger grid than a 6 or something like that. Okay. So, generally an 8 by 8 meter grid is a good grid to go for in hospitals, because it is able to take an operation theatre, intensive care unit, laboratories, radiology department, comes better with an 8 by 8 grid. But if you are doing a public hospital or a charitable trust hospital or a nursing home, smaller, then probably you could look at a 7 to 7.5 meter grid. Also important to understand is 8 by 8 meter grid allows you 3-car parks in the basement. Anything less than that, you will get only 2 cars, and which is a problem. This I learned from Hafiz contractor actually when we designed Hiranandani Hospital. Till then we used to go with 7.5 meter. So Indians are generally known to be conservative in terms of whatever we do. छोटे में कितना benefit मिले, that is the whole thing.
Efficiency. Mileage कितना देता है?
Yeah. That has been done into us, but in hospital and healthcare that doesn't work. And this basement thing was really important because if 2 cars versus 3 cars makes a hell of a lot of difference for us when parking norms are becoming more and more stringent. Why this grid we take is I'll show you in the next slide. It is able to take a twin room. Okay, on your extreme left on the top is a single room, and on the other side is a twin room. So you can see that the same grid is able to accommodate both the rooms, and the middle one, when I am removing the wall in between, I am able to make it a square wall. Okay, so that's why that grid becomes important for us, and it should take all of these together. All right, that's why this is important. And the next step, after you have done the space program and the grid and the footprint and all of that, is the stack planning. All right. So so once you have done a space program, once you know what's your footprint, the ground coverage, and all of that, then the next important thing is how you stack the departments. Okay, because stacking in hospitals is related to adjacencies also, and what needs to come closer to what, right? That ICU, surgical intensive care unit should be closer to operation theatre. Emergency OPD need more of radiology and interference, so they should be close to each other, like that. So maternity services will be close to neonatal intensive care. Okay, like that you will need to do that. So when you do it, you will get into something like this. Okay, so this is a cancer hospital project that we designing, which probably will come up at the Somaya IOBR land in Sion. Okay, so this is what you see in that red is the linear accelerator. You can see the thickness of the slab. It's almost 6 meter. Okay, we put it in basement so that down below you don't need that thickness. There is earth right below, but it's a 6 meter or 6.5 meter height. Okay. Now up to I think fourth floor, you have a plinth which is much wider, right? After that, it is reducing because
they went back again.
Okay, so what I am trying to say here that if you look at up to fourth floor where we have the service floor, and you will understand that service floor government gives free of FSI, but the height is restricted. You cannot make it more than 2.4 meter height. Okay, so the idea is that you should not use it for purposes other than engineering. All right, so that is why that service floor is the buffer floor, and after that all inpatient wards. So this is a podium tower kind of a design, where the podium which takes all the diagnostics and therapeutic, departments up to the operation theater, which is the last floor, and after that, you put the service floor and take the building up. So this is a kind of a stacking plan, where you are also giving the section, in terms of what's the height. Okay, so this is something that gets done the next. All right. Now I'm going to touch upon a little bit of something which you probably would not be doing, but I think for us this is very important. So we have 3 engineering services, electrical, air conditioning, and plumbing, right? So how do you go about doing the basic? This is only basic, don't worry about getting into too much of detail. You need to understand we need to understand what is the load, first of all. Okay. So of both medical, non-medical, electrical, air conditioning and all of that. So number of electrical points, so when you do a space program, what we do is we use that room and we create something which is called as a room data sheet. Please write that down. It's not written, I think, is there. The room data sheet is something which you should do for other buildings also. So what it does is, it tells me, so how a room data sheet will look like is like it will be an Excel sheet. So it will say, OPD 1. So it will say I need 4 plug points. Okay. I will need 4 lights, 1 fan, air condition, 1 basin. Okay. Oxygen suction, yes, no, like that. So when I do this room data sheet for the 1,000 odd rooms in a hospital, it gets me all this data, immediately. Okay. So now suppose if I do a room data sheet for an intensive care cubicle, there what will happen is, because it's a life-saving kind of area, when I say supply as raw, emergency or UPS, then I will need to do that plug points with UPS, because anytime, in a life support, they say a ventilator, which is used for artificial breathing, cannot go shut, right? You cannot have an operation theater which while you are doing an operation the lights go off. That will need to be backed by UPS. You cannot have a blood bank refrigerator, without a power. Okay, so that needs a UPS. So that 30-second, 1 minute on UPS, and then the DG kicks off. Okay, so this is important for us, and we are, like I said, 365-day kind of a system. Okay, then air conditioning load is about 1.5 kilowatt per ton. Right, so that's a pretty heavy load which will happen. Then there are certain lighting and lux level calculations which is given in a standard, which you can see off the internet. You will find that. Of course, you have to then decide cabling routes. So exposed versus concealed. So if you want a concealed cable, then your interior design planning has to be complete in all respect, because you then otherwise cannot keep chasing the walls. Okay. So in public hospitals, we generally propose to give exposed only, because that's probably better way to deal with it. But concealed, everyone likes it, no doubt about it. Then there is something called building automation system. I hope you guys have heard of that. Suna to thoda Google karna hai. It is important because in the long term, it helps you save energy. Now, air conditioning. The first question is whether you want central or partial. What would you want? The first is to do central air conditioning if that's possible. Okay, but it's expensive, both capital expenditure as well as operational. So many hospitals decide not to go for it. Okay, And if you don't do it, then your design has to be such that you are able to access natural light and ventilation both. Okay, so you cannot have a very fat or a very broad footprint because that will cut the light. You will need to then puncture the building with some, courtyards, etc. Then you go about, heat load calculation. So uske andar, you need to understand that if you do a glass facade, okay, that means you are bringing in a lot of heat, right? So if you do that, then you have to be careful, because then you cannot have, the what do you call, bring in that much light. So you should be careful. So you have hospitals. We did one in Jaipur where the entire building top to bottom is glass. Now that was an owner's requirement. I tried to argue with him, her rather, the owner's wife, and it's a very big hospital. They put glass worth about, I think, 11 crore. Okay, just for the glass facade. That was stupid actually, in my opinion. But because it brought in that much heat, and then I have to cool the building from inside that much, isn't it? And look at the cost. Okay, 1 ton per 20 square meter, and the cost is 1 lakh per ton. Okay, it's not 25-30,000 what you read in newspapers. So that's one of the problem. So get into this habit of something which is called as a life cycle costing. Have you heard that word before? Naam suna? No. Okay. So tell me whether you would like to buy a diesel car or a petrol car. Why diesel? Because diesel is a cheaper fuel, right? But in the long run, if you do a 5-year calculation, petrol car is cheaper. So that is called life cycle costing. Means you buy an asset, you own it, and then you over its life, how much it costs. Understood? So that is why in air conditioning you need to do that, because hospitals are 24 hours, 365 days. Alright? So that is an important aspect that you need to learn. Now for us, there are very strict quality standards, and there is an organization called NABH, National Accreditation Board for Hospitals. And those standards have to be met for as far as operation theatres and other areas go. Okay. So there are certain filtration requirements, if you will see. Okay, that HEPA filter is required in an operation theatre, which takes away 0.3 micron particle. Okay, this is mandatory in operation theatres. You can't escape it. Alright. Then there is something called as isolation room. Have you heard this name, isolation? Have you heard the name organ transplant? Kidney transplant, naam suna? Yes. So kidney transplant will be a positive isolation room. Means when you do transplant, आप मरीज का immunity को कम कर देते हैं by giving medicines. Okay, so that he accepts the transplant, properly. But when you do that, he is more susceptible to infection. So in the room in which he is recovering for 2 or 3 weeks, that room needs positive isolation, positive pressured air. That means whenever you will open his door, air will always go out. Okay. So positive isolation room as mandated, 1 per intensive care unit. Okay. And negative isolation लगेगा जब आप कोई infected case को treat कर रहे हो. Okay. Then it is reverse. Then you will reduce the pressure so that any door opens, air will go in. Alright. So these are some of the nuances. Now look at some of the plumbing data. Alright, 500 to 800 liters of water provided per day. Okay. So this includes laundry, kitchen, air conditioning requires a lot of water. All of that is included. Then we need hot water, cold water. Suppose you are designing a hospital in Jammu and Kashmir. Okay, you will need hot water surely. But in other North India, you will need that. You know what is WTP? Water treatment plant. So we designed hospital in Mira Road in Bombay, है ना? पूरा hospital बन गया और फिर समझ में आया कि हमने वाटर ट्रीटमेंट प्लांट लगाया नहीं, म्युनिसिपैलिटी पानी देता नहीं है. तो आप टैंकर का पानी लाएंगे तो you have to treat the water before it comes into the building, right? Water treatment plant is important, and before you design a plant, you need to know, you need to test the water of that area. कि आप समझो अपने नॉर्थ गुजरात में सूरत में हॉस्पिटल बनाया, very high salt content. Okay, so you need to treat it. Otherwise, what will happen is your entire plumbing line will get scaled.
Yes.
थोड़े सालों में ब्लॉक ही हो जाएगी. So that is an important thing to understand. What is STP?
Sewage treatment.
Sewage treatment plant is mandatory for any hospital more than 100 beds. और सीवेज ट्रीटमेंट प्लांट का आप पानी कहाँ पे यूज कर सकते हैं? Anyone? Only gardening. So I stay in a 40-story tower in Goregaon, and we flush our toilets with all STP water. Okay, but for that we have to ensure that maintenance is proper because it otherwise starts smelling. Also, STP water can be used for makeup water of air conditioning. Okay, air conditioning अगर आप देखोगे तो है ना, कभी छत पे जाएंगे तो you will see something water flowing, that is cooling tower. तो वो पानी एयर कंडीशनिंग में से आता है, ठंडा करना पड़ता है. So when you cool it, 30% will evaporate. That needs to be fed in again. So this water can be used. Then we need reverse osmosis for dialysis patients. Deionization plant for laboratories. Okay. अच्छा, आपने हाइड्रोनोमैटिक सिस्टम नाम सुना है? सुना है कि नहीं? Okay, so that is important now. We don't use no longer the traditional gravitational pull for water. है ना, कि टांकी ऊपर बना दी, नीचे नल खोला, पानी आ गया, वैसा नहीं चलेगा, है ना? Because if you have hospitals of 19 stories, 10 stories, 20 stories, है ना, ऊपर वालों को बेचारे को पानी नहीं मिलेगा, सारा पानी नीचे में ज्यादा जोर से आएगा. Okay, so nowadays you have hydrodynamic system. It works with pumping and vacuum. So that whenever you open a tap anywhere, same flow. Rainwater harvesting is a must. More than 1 lakh square feet of a building anywhere in India, it is mandatory as per NBC to have rainwater harvesting mechanism. Okay, somewhere we have lost this, touch with reality, and आप कहीं fort में जाएंगे तो आपको हमेशा you will find a pond in middle of the fort, any palace or any fort. That all we have forgotten, and we have concreted everything which is around us. है ना, कहीं भी जाते हो, मॉल जाते हो, किधर भी जाते हो, सब लेके concrete. पानी जाएगा किधर? There is no seepage, so you should generally do a grass paver mechanism wherever as architects we can. Okay, so that at least there is some percolation of groundwater. Okay, let me just talk about where is the toilet location. So these are two types of toilets. Okay, one is towards the window, and one is towards the corridor. Sorry, these are both towards the corridor. Okay, and this is the one which is towards the window. Which one will you prefer? Which one will you prefer? हाँ? जवाब दो भाई. This is toilet towards the window, and this one is toilet towards the corridor. Which one will you prefer? Why? Suppose वो जो patient पढ़ी लेटी हुई है, बेटा से लड़की है, लाल कपड़े में है, so she is going to see a better view out of the window with this, or she is going to get a view out of इसमें तो उसको दिखाई वो दिखेगी नहीं, है ना? So generally we tend to take toilets towards the corridor, and that is why 5 minutes back I told you of the service floor. Okay, take the toilet towards the inside, at the service floor you bend the pipe, take it out of the building. Okay, जैसे hotels में होता है. So there is the same kind of a situation which happens nowadays in hospitals. Idea is to give the patient full window, bring in more light. The recovery of patient is also better with natural light. Okay. So this is outboard toilet, inboard. There is one more option like this, which we have tried in some places, but वो back to back toilet होने की वजह से plumbing थोड़ा सा difficult हो जाता है. But NHS, which is National Health Services in England, follows this design. Okay. Please. Alright. a little bit about some newer kind of buildings which are happening now. Have you heard this pre-engineered building as a concept? So we did this hospital in Delhi using uh, uh, steel structure, and the lady who was to talk, whom I am speaking here, she is the one who designed this. This is the entire structure went up in about 60 days. Okay, 80,000 square feet in 5 floors. It was very fast. Okay, so this is something that India should try, and Apollo is going to do one. Fortis is doing one. Government is also thinking of using this technique to build faster hospitals in rural areas. Okay, using prefabricated. So here हमने external walls भी polystyrene foam के लिए थे. If you know Palladium Mall in Parel in Bombay, okay, Palladium Mall नाम सुना हो आपने. So there this was polystyrene foam external walls. Entire external walls we were able to finish in I think less than 3 weeks. Okay, because it is 10 feet wide, polystyrene foam board which even a child can put, pick up and put it. All the internal walls were using dry walls. Have you heard the name dry walls? Yeah, have you heard the name? Huh? Yes or no? Yes. Okay, so drywall is nothing, but it is an aluminium frame, and then there is अपना जो gypsum board दोनों तरफ से लगा देते हैं. Okay, and there are 2 sheets of gypsum board so that even an impact is able to not नहीं तो क्या होगा जोर से धक्का मारेंगे तो फट जाएगा. Outer board is tougher, at the inside. So the advantage of this drywall is that एक तो वजन कम हो गया structure become lighter. Implementation is faster. कोई curing का जरूरत नहीं है, कोई plastering का जरूरत नहीं है. Okay, कोई chasing का जरूरत नहीं है because inside is hollow, so you can move your pipes, conduits, medical gas, everything inside the wall. Okay, noise का problem नहीं आता. आप उसमें वो wool, glass wool क्या बोलते हैं वो डाल दो, वो भी हो जाता है. And to say renovate also it is very easy. Okay, so it's environment friendly. We are now most of our hospitals we end up using drywalls. Little expensive, maybe about 10% more expensive than the normal wall, or maybe 1%. At the end of the day, it's faster. So people are looking at that. Deck sheets, I don't know. Have you heard of deck sheets ever? ये भी थोड़ा सा गूगल करना है because ये deck sheet में क्या होता है de-shutter करने की जरूरत नहीं होता once you put a slab. Okay, so that's another fast way of construction. We use not tiles but vinyl flooring in areas where we don't want infection. So we don't want any joints in the flooring. We use vinyl flooring. Okay, which is jointless, and they come in long sheets at the corner, at the edges of the room, which will be right angle otherwise, but with vinyl flooring it becomes a cove, rounded हो जाता है, तो उसको साफ करना भी आसान हो जाता है. So all intensive care, critical care, operation theaters, we use this kind of vinyl flooring, kind of thing which is there. Okay, so this is a little bit about. So this is the photograph of how the structure. These cross bars that you see are brace, for the earthquake, in 2 earthquakes, and there has been absolutely zero crack. Okay, this is what I was trying to say about the drywall system. That most important is point number 3: the ease of running services in wall cavities without chasing the walls. This is why we prefer it. Okay, and it's a smooth finish, so zero requirement of UV punning. Right? Then this is okay, energy efficiency. Why go green is important for you to understand. With the next slide, this is why. हमारा हॉस्पिटल सेंट्रल एयर कंडीशन होता है. आजकल तो कोई भी कहीं भी घर भी जाते हो तो बच्चा पहले जाकर के एसी चलाने बोलता है ना. गाड़ी में बैठते हैं तो पहले तो मालिक केवल एसी में जाता है, तो ड्राइवर भी एसी वाली गाड़ी में ही जाता है ना. He doesn't roll the glass down. Everyone has become used to air conditioning environment. Also, air conditioning allows you to control the quality of air in hospitals. That is important. The future mostly are going to be air conditioning, but electricity consumption and DJ extremely expensive. So that life cycle costing phenomenon of HVAC is very, very important. For one bed, we did a survey for Confederation of Indian Industry about 7 years ago. and we found that hospitals spend about 600 rupees per bed per day on electricity alone. है ना?
Hmm.
तो 600 रुपए का तो वो हो गया, 300 रुपए का खाना हो गया, तो 1000 रुपए से कम में तो जनरल वार्ड का आप क्या खर्चा रखोगे, है ना? So still everyone feels that how general ward is so expensive, but the cost only is becoming so much. Even lighting, if you see, is 21%. Both
Hmm.
together, if you put good brains in designing, you can cut this cost quite a bit, and the investment will pay back for itself. Okay, and these are some things which you probably know it better. Solar heaters is there, but it needs larger surface area, so becomes difficult to do in vertical structures like in Bombay. But in a campus kind of situation for a medical college or something, we definitely use solar panels. Okay. Rest of it, what I was saying, that enough soft skip to replenish groundwater and grass pavers. Please, wherever you design, whatever you design, forget not only hospital but whatever, please try and do, save this part of it at least. If you are forced to use glass, then use high performance glass because it reduces the heat, it allows light, to come in, it's good penetration, and it saves 35 to 40% of electricity to cool the. Of course, cost is higher, hence I am saying that whenever you are forced to use, then use high performance glass. Okay? Water conservation, we know that now there are waterless urinal, electronic sensors, less water. Even at airports, now have waterless urinals. So we need to do that. We need to use the STP water. So STP helps regenerate 70% of the water. Okay. Generally क्या होता है हम लोगों को ये मालूम नहीं होता है तो हम ये करते ही नहीं है. But once you know that this is the advantage of doing it, you probably will end up doing it. Okay. So it's always better to educate ourselves. Right. And there's a lot of technology that is being used, for transferring data, filmless, paperless hospitals, minimizes time, there is a whole gamut of telemedicine services which allows, patients to be treated remotely. Okay, so all this is now coming in healthcare in big way. Okay, so your hospitals will have to be designed smart with use of these technologies. Okay, it also means lesser spaces because technology allows you to do multiple things. This is the last slide, and I like that the last line is in red. Okay, we have to think, get into this mold of less is more. Okay, नहीं तो बड़ा लेके तो हर कोई बना देगा, but you need to have a compact, well planned, value for money hospital. Okay, तो एंड में कितना देती है वो, that is important what should be. Okay, all right. So thank you very much. I hope that I've been able to give what you have desired.